Greetings, everyone, and welcome to today's escape room webinar where we are going to escape from IP addressing issues. If you were with us in previous webinars, we've escaped from routing issues, we've escaped from switching, layer 2 issues, and now we have to escape from IP addressing issues. So the goal today is to help me escape from 3 different scenarios. And then once we're out of all 3 scenarios, we'll be able to call it quits for the day. So the important thing about today's webinar is that you play along. So it's really great if you have a paper, pencil, pen, scratch paper, whiteboard, doesn't matter, just something, because when we're dealing with IP addressing, we might have to jot things down really quickly so that way there we can figure out what actually is wrong. And you'll see me do that today right on the slides, on the screen, as we progress through to help escape. But I'm going to need your help. You're going to have to tell me what commands to input on devices so that way there we can ultimately figure out what in the world is wrong. But more importantly, why it's wrong, how we determined it was wrong, and ultimately in the end, how can we solve that particular problem. All right, so here's today's topology, folks. It's our Cisco CCNA topology that we use in our Cisco CCNA class. We use it in Encore as well. So we have some PCs on the left-hand side, access layer switches, distribution layer switches. We have some core routers. We have a branch office over here. And out here is the internet. So our very, very first escape room, here it is. PC1 is informing you that they can't get to the internet, but a friend that sits next to them can. All right. It's all we know so far. So 8888 is the IP address we're going to use as the internet IP address today. So yeah, the internet is down. And the goal here is to figure out why that is and fix it. So there's not a whole lot of information that you have right now, folks, but really let's just start brainstorming here. You know, what maybe should we do first? Where should we go first? Right? It could be a bad patch cable, but for this escape room, there is no physical connectivity issues. Because it'll be very hard for me to run to the room and fix the physical issues. All right, is the server down? Okay, well, we know the server is not down. Why? Because the friend that sits next to them can. So it's not the server specifically. We're just saying the internet in general in this case. So PC1 can't access the internet at all. That's what they say. PC2 can access stuff. So what do we see here? We see things like, let's go ahead and maybe do some trace routes, do some IP configs. Let's check things like the default gateway. Let's do some pings, right? That's always a really great place to start, folks. It's good to, as I like to call it, verify the actual problem. Because if you don't verify the problem, what if all of a sudden, right, PC1's computer's just working now? You don't want to waste your time looking at routers and switches and everything else and ultimately determine that, oh, wait, everything's perfectly fine. So let's go over to PC1 first, and it would be advisable that maybe we just issue a ping in this case. So let's go ahead and ping 8.8.8.8, and we'll confirm here that they cannot reach the internet. Now, even though it says reply, you always have to be careful when troubleshooting in your environments, because typically you see reply, you think, oh, it's successful. Double check to see who that reply is coming from. In this case, it's 10.0.10.10, destination host unreachable. So the question now is maybe who's 10.0.10.10? We might want to check that out. Well, I'll tell you who it is. That is PC1. That is PC1's IP address. So they're telling themselves, they are replying to themselves that the destination host is unreachable. Now, they claim that their friend that sits next to them can reach. Well, let's just double check that, because maybe they can't. You know, folks, if they can't, then we know that we have a bigger issue on our hands than just one single device. So by just doing some simple, small, minor tests here, you have the ability to start kind of figuring out how big is the scope of this problem we actually have at this point in time. All right, and if you look in our topology here, PC1, its default gateway is going to be DSW1, so there's an SVI on DSW1. Right? So what is the actual IP address of our default gateway? That's a good one. That would be excellent for us to check out. So somebody says, let's go ahead and ping the default gateway. So let's go over to DSW1 and see what we have for some IP addressing on DSW1. So first of all, if I type in show IP interface brief, we're going to see here on DSW1 that we have VLAN 10 with an IP address of 10.0.10.1. 10.0.10.1. And so let's just confirm. Folks, is 10.0.10.1 a valid IP address in that subnet? Yes or no? You know, why do I ask that question? I ask that question because you always have to remember your default gateway has to be in the same subnet that you are in. That's what we need. We need that. Because everybody in the same subnet VLAN broadcast domain has to have the ability to communicate each other at layer 2. So as a result, you all have to have the same IP addresses. You all got to be in the same subnet. The addressing has to be proper. So how can we figure out the actual IP addressing range here, folks? That's going to help us out. We need to know our IP addressing range for that subnet to know all the total possible valid IP addresses. Well, we can take our subnet mask in this case, and we can figure out our block size and determine ultimately what we're counting by. So in this case, a /27 has 8 binary ones in the first octet, 8 binary ones in the second, 8 in the third, so that's 24, 25, 26, 27, 28, 29, 30, 31, 32. So 32 total bits in a subnet mask, 27 of them are for the network. And a good chart to know when you are dealing with stuff like this, when you don't have a subnet calculator, is your powers of 2. So we'll start off 128, 64, 32, 16, 8, 4, 2, 1. And then we can start comparing right here. I look at this very last one, and I can see it would line up right here because we'd have 1, 1, 1, 0, 0, 0, 0, 0. So this is telling me here that we are counting by 32 in the fourth. That's what it's telling me. So my very first subnet with a /27 mask would be 10.0.10.0/27. The next one, the next network ID, the next subnet with a /27 would be 10.0.10.32/27. So what does that mean? It means in this space right here, our valid IP addresses are from 10.0.10.1 to 10.0.10. Well, if the next subnet's 32, our directed broadcast address would be 10.0.10.31. So the last usable is 30. So 10.0.10.1 is definitely part of that network ID. So we now have to ensure that the end users in that exact same network as well. Okay. Now, the question is, though, is that really, though, the IP address of our default gateway? Let me ask you this, folks. When you have multiple default gateways for a single subnet, right, multiple routers that can act as default gateways, let's put it that way, what typically are you running in your environment as well? Because if I go over right now to DSW2 and I type in show IP interface brief, what am I going to find? I'm going to find another SVI, another layer 3 interface for that subnet, 10.0.10.2. So I could use either of these as my default gateway. And if I want to, what would we typically run in order to accomplish that? What do we call that technology? What do we call that service? Curtis, great job on that host range. Well done. Yeah, so a first hop redundancy protocol, such as HSRP or VRRP or GLBP. And in this particular case, if we examine DSW1 and we type in show standby, that shows me if I'm running HSRP. And in this case, we are running HSRP, right? So when we analyze this IP address, because we're using HSRP, you'll see it's configured on DSW1. We'll go over to DSW2. Oops, wrong command. There we go. It's also configured to use that particular address, 10.0.10.3. So with that in mind, that is what our clients are going to be using as their what? As their default gateway. 10.0.10.3. 10.0.10.3. That's what they're supposed to be configured as. So let's go back to our client and let's ping to our default gateway. Okay, so we can actually ping the default gateway. That's interesting. We can ping the default gateway. Typically what that tells you is that there is nothing wrong inside your layer 2 network. Nothing wrong inside your layer 2 network at all. So I'm going to try to ping the internet again. Can't get there. What is one more thing? Good, Curtis, thank you very much. That's exactly it. There's still one more thing we haven't checked on PC1. And that is what? What is the one thing we should have done right away? Right away! That I failed to do. Making my escape room a lot harder to escape out of. Yeah, check the actual config on the PC. A lot of you said that first. Great job. Congratulations. I'm with you on that. And I took the other route to show you that you can make it way more complicated than it has to be on yourself. Right? But IP config. Right? Check that out first. Verify everything on the device. All right, what do we have? We have our MAC address, static IP addressing we're doing, so that way there I can actually do these demos. All right, what do we see? What do we see? Yes, there you go, right? Look at that. Wrong default gateway. Now, I think many of you are saying, well, if you're using DHCP, Raymond, that wouldn't happen to you, right? And some of you are probably going, yeah, and if you did this, Raymond, on your PC, the PC would actually yell at you and say, you know what, that's not right. That doesn't make sense. But it'll still accept it and it'll still try to use it. So, yeah, you can make mistakes, especially when you're doing static configs. Typos happen, exactly. What is the typo here? Just a 0 is missing, right? That's all it is. 1 0 is missing. Now, this is what I want to talk about next is, so what is actually happening because of this now? Why can't we actually get there? So, yeah, we have an IP addressing issue, great, but what is that causing? So let's examine this for a second. Consider this. When you are on a PC, and you open your web browser as an example, and you're trying to go somewhere like www.stormwindstudios.com, right? This web server out here, right? What does your PC have to do, folks? It has to take that whatever you're trying to do and start creating PDUs, right? So we have our data PDU, which is the data that we are trying to transmit along with the application layer protocols that we're using. So in this particular case, HTTPS as an example, and the data that goes along with it. So this is like an HTTP GET request that's happening right now. And then you have to start encapsulating. This is going down the TCP/IP stack, OSI model, right? So what happens now is you go to your transport layer, you create your segment, you're going to have to put your source and destination port numbers in, and those are based on the well-known ports, the registered ports, the dynamic ports. And then you take that segment that you created and you got to create a packet out of it. So you have your source IP address that goes into the packet, which is your own IP address, right off your device. And then the destination IP address is going to be determined using something like DNS, because www.storewindstudios.com has to be, we got to get the IP address of that for the destination IP. So once that is done, we can go ahead and take that packet and build a frame out of it. So when we build our frame, we need our source MAC, which is going to be our own MAC address. So in this case, this particular PC's MAC address is 0011, as you can see. So that's going to go in there. But now when it comes to the destination MAC, how are we going to get the destination MAC? Well, it depends whether the destination you're trying to reach is in your own subnet VLAN broadcast domain or whether it's in a different subnet VLAN broadcast domain. And the way your PC figures that out is it takes its own IP address and its own subnet mask. And then what it'll do is it will identify, based on binary bits, its network portion. So taking its IP address, its subnet mask in binary, figures out its network portion. It then takes the destination IP address and looks at the same binary bits in the destination IP address as its network binary bits. It compares the two. It's called the ANDing process. And if those binary bits match exactly, they're the same between the one sending and the destination, then you ARP for the MAC address of that device you're trying to talk to. However, if the destination is outside of your subnet, meaning that when you do the ANDing process, those binary bits don't match at all, well then, you ARP for the MAC address of your default gateway. So if you already have the MAC address of your default gateway in your ARP cache, then you're just going to go ahead and use it. But if you don't, you're going to have to send out an ARP request, which is broadcasted in your own subnet VLAN broadcast domain. It goes out on the network. And in this particular case, you're ARPing for the MAC address of the default gateway. So if the default gateway owns that IP address, it's going to give you its MAC address. So here's the problem we're running into in my scenario right now. Because PC1 is configured with 10.0.1.3, it's going to send out the ARP request and saying, hey, if you're 10.0.1.3, give me your MAC address. Nobody responds because they don't exist. That's all that's happening here. We can't even send anything right now. We're stuck trying to build a frame. Right? The PC's not even sending the ping in these cases. When I'm pinging, they're not even going. They're not even leaving. And the reason why is because I cannot get the MAC address of the default gateway, 10.0.1.3. So we look at our ARP cache, it should not be in there. And it's not, as you can see. Right? That's why it's failing. Not even able to send it. So once we fix the problem, let's go ahead and do that. I typoed that one incorrectly this morning. Look at that. All right. Okay. And then check out our IP config. You'll see now we're 10.0.10.3 as the default gateway, which matches our first hop redundancy protocol. And now you should be able to ping and everything should work just fine. Perfect. All right. By refreshing your browser. Love it. All right. So yes, Windows will actually, somebody says, Windows will actually ARP for the default gateway even if it's outside the subnet and try to use it? Yes, absolutely. It's trying. So again, these are Windows PCs. Linux might react differently. Your Android phone, your iPhone may act a little bit differently, but in most cases, you're not going to be able to get, well, not in most cases, all cases, you're not going to be able to get the MAC address of the default gateway in all those cases. All right. So that's escape room 1, folks. So I'm out of the door, and now I'm in escape room number 2. All right. So go ahead and read this scenario, folks, and read it very, very carefully while I make a few adjustments here on my devices, so that way there we can try and escape again. All right. Yes. I'm just doing a configuration replacement on a few devices. I won't tell you which ones or else you'll know what's going on. All right. And one more to do, and then we'll be good to go. Nick says, I doubt it's going to be the default gateway this time. Love it. What if proxy ARP was turned on the router? Okay. So somebody's asking, what if proxy ARP was turned on the router in the last example? So the only time proxy ARP is going to work is if the default gateway has a route to get to that destination network. So if it doesn't have a route to get to that destination network, then it's not going to respond with its own MAC address. So typically routers have default routes on them, so that qualifies for proxy ARP. So yes, if proxy ARP is enabled, then your route, your default gateway would respond with its own MAC address, and PC1 would have connectivity. That's a great observation. Very great observation. Yeah. And yes, my routers have proxy ARP disabled because it is a recommendation in the real world not to allow your routers to do proxy ARP. Because when they do proxy ARP, it is possible that you can overwhelm the ARP caches on those routers because they're responding for networks that they shouldn't be responding to. So it's not a good practice to have proxy ARP on. It should be off on your devices. All right, so in this case here, PC2 is informing you that they can't get on the internet, but a friend at PC1 that sits next to them can. So now they are both questioning PC1 and PC2 if you have something against them, right? Because for some reason they keep being the ones that have the problems. PC1 and PC2. All right, so what do we want to do here, folks? I think we learned our lesson in our last example that first and foremost, we want to verify the problem. So we're going to ping from PC1. It works. All right, that's good. Let's go ahead and ping from PC2. We're going to ping, and it times out. Times out. Okay, so definitely not working. Yes, it's possible PC1 is upset with the first issue and decided to disable PC2's next. That's a possibility. All right, so we also learned in our last that we should definitely be checking our configuration. So I'm going to type in ipconfig right now. .10.0.10.20. So yes, that is the IP address that we want on PC2. That is is that the right subnet mask, folks? I'll just make this a little bigger for you up here. 1 second. So is that the right subnet mask for PC2? Is a /27 actually 255.255.255.224? Good. Awesome. And the default gateway we learned in our last one is definitely going to be 10.0.10.3. So it looks like we're configured correctly here so far. DNS. So we're not worried about DNS because we're not doing any type of name resolution here, all right? So we're leaving DNS out of all of our examples, all of our scenarios, and it's basically straight up trying to connect to things based on their IP addresses. So we're not going to worry about DNS in these cases. But, DNS could be affected if we're not getting the right information from DNS, or the DNS is returning the wrong IP address, or we're configured to go to the wrong DNS server. Many different things can come up as well. All right, so somebody says, can we ping the default gateway? Let's give it a try. Ping 10.0.10.3. So I can't even ping my default gateway. Okay. Now somebody said, let's trace. Okay, trace. Let's trace 8888 TRACERT 8.8.8.8. I do like that. Wow. Nope. All right. So did somebody pull the patch cable? It looks here like I open my network settings. No, it's good. There's something plugged in. Looks good to me. Yeah, default gateways, first hop in a trace route. That's true. Go to ASW2, folks. Might as well. Are we learning, or ASW1, I should say, are we learning PC2's MAC address? Should we check that out? Do we want to check if we're learning PC2's MAC address to see if it's even communicating? Should we do that? I like that. That's a way you can verify if you have connectivity between, let's do dynamic, between your end station and the first switch. So what's the MAC address of PC2? We can do an IP config, switch all, and we'll see here 0022. We'll just use the last four options here. And there it is. All right, so we do have connectivity. So for all of you wondering about the cable and connectivity and all that, we do have connectivity. So based on the subnet information here, the subnet is correct. We just verified PC2's IP addressing information, subnetting information down here. Are we plugged into the right VLAN? Okay, good, great. How do we check VLANs on iOS switches, folks? How do we do that? All right. Now, I don't really have to do this, folks. And why is that? Because we can verify it right here. You see that? I can verify it right here. It says VLAN 10, but we'll check anyways, just in case there's a discrepancy. But there shouldn't be. VLAN 10, gig 102. That is gig 102. I promise you that. So that is correct. It is 102. That goes down to PC2. All right. Let's do that. I wasn't thinking of testing that, so ping 127.0.0.1 to make sure the TCP IP stack's working fine. Looks good to me. That's a good one. That's a really good one, Bill, by the way. Thank you very much for that one. Ping its own IP. All right, we can ping ourselves too. So it's all good. Strange. Okay, folks, let's get back here on track. All right. Remember, we're dealing with IP addressing issues. So let's not worry about ASW1 too much here right now. Right. So if we don't seem to have an IP addressing issue on PC1, and PC2, where else could we have an IP addressing issue that could affect what's going on here? Yeah. Here we go. right? Who else is in our subnet that we rely on to get out of the subnet? Yeah, it's going to be our default gateway. That's what it's going to be. So let's go ahead now and start taking a peek maybe at some of the addressing here. So we're using an SVI. So we'll type in show IP interface brief first. We can check our SVI IP address. Right, so it's 10.0.10.1. But that's not what we're using as our default gateway, if you remember. We said we're using 10.0.10.3. And that's supposed to be part of show standby. So let's take a peek at that. All right, it's there. So we got to confirm these addresses as well. What else should we confirm? So, Jonathan, what you said that. So, what do you want me to check? What would you like me to check? Okay, well, if I do that, that's not going to give you any more information than we already know. Okay, so, but where else can we get the information you are looking for? I think I know what you're looking for. Yeah, let's try. Okay, so let's try show IP interface VLAN 10. Let's try that. All right. Anything weird here? Anything wrong here? Look at that. Look at that. Remember that we have a /27 for that subnet. And our PCs are configured with /27s. The router's configured with a /28. What about DSW2? Same thing. All right. So let's do a little bit of calculating here. So we know right now that with our /27, as we talked about previously, we are counting by 32. So I'll quickly do that one again. So 27/27 is going to be 8, 8, 8. So 24, 25, 26, 27, 28, 29, 30, 31, 32. So if I do 128, 64, 32, 16, 8, 4, 2, and 1, and we compare all of these, well, this one sits right here because it'd be 1, 1, 1, 0, 0, 0, 0, 0. So we're counting by 32. So we said that that would be 10.0.10.0/27 all the way up to the next one, which is 10.0.10.32/27. So all the valid IP addresses are 10.0.10.1 to 10.0.10.30. Right, so there's the valid ones in that. So if we look at a /28 now, if you look at a /28, we would have counting by, so 8, 8, 8, 24, 25, 26, 27, 28, 29, 30, 31, 32. That's counting by 16 now. So if we're counting by 16, that means 10.0.10.0/28 is the network ID, and you'd have 10.0.10.1 to 10.0.10.15 with a directed broadcast address of 10.0.10. No, it'd be 14 with a directed broadcast address of 15. Okay? So why, though, is this a problem on the router? Why is that a problem on the router? Well, let's take a peek at the routing table right now. So, traffic right now. No, we want this. So, traffic right now would be leaving PC1 first, going out, being routed all the way to the internet, and it would come all the way back, and DSW1 would see 10.0, so 10.0.10.10 as a destination IP. Does 10.0.10.10 fall within that space? Does. So we successfully build our frame and send it down to PC1. Okay, now PC2 communicates and it arrives at the router. What does the router do with it? Well, if it's going to the internet, it follows the default route and away it goes. It goes. It gets all the way to the destination and it comes all the way back and it gets to our router DSW1. And now DSW1 looks at that and goes 10.0.20, 10.20. Do I have an entry for that? Do I have an entry for it? Well, the answer to my question is actually yes, folks. Yes, that's right. It is yes. Why? Why is the answer yes? Because of this one right here. Oh, no. So where is it going? It would go back that way. Now, in reality, if we really think about it further, though, it wouldn't even make it back to DSW1. Why does it not even make it back to DSW1? Because R2 would not even know how to get there either. So R2 would not know how to get there either. So in reality, it's going PC2, DSW1, R2, out to the internet, gets back, and R2 doesn't know what to do with it. Because that value now, it's got nowhere to send it because R2 does not know about, it would know about this network as well. /28, it would not know about the /27. Yeah, so that's what's happening there. So to fix the problem, I got to fix it on both routers. I can't just fix it on one router. So configure terminal interface VLAN 10. My IP address is going to be 10.0.10.1 255.255.255. Can anybody help me out? I'm stuck. Yes, good job. 224. Perfect, because it's got to match what we have in our diagram. So perfect. All right, now let's go over to DSW2. Configure terminal. Interface VLAN 10. IP address 10.0.10.2 255. Nope, not 25. Woo! 224. There you go. Perfect. So now if we go back to the PCs, PC2 should be able to ping just fine. Nah, I don't like saving my config because nothing could go wrong, right? Nothing could go wrong. Question coming in. Does anyone know why you can't provide IP addressing in CIDR on Cisco? Okay, so it's not a Cisco thing. It's on an iOS by iOS basis. So some operating system that Cisco provides lets you use CIDR. Some don't let you use CIDR when it comes to the IP addressing. the iOS operating system is one of the older ones, and that's the way it was done back in the day, and it's just stayed that way ever since. Curtis, why would PC1 have to be reconfigured? PC1 doesn't have to be reconfigured because it was configured properly to begin with. So PC1 and PC2 were both configured properly to begin with. It was just the router interfaces that were configured incorrectly. That's it. It was just the router interfaces that were causing all these issues. Oh, we got one more. I exit out of this escape room, folks. I got one more to go into. Here it is. This one's a little bit longer. Take your time to read it. I'm going to go ahead and make my adjustment right now. All right, here we go. Escape room number 3. PC1 and PC2 are now informing you that getting to the internet is hit and miss. They tell you that, sometimes it works and sometimes it does not. Sometimes pages load properly and sometimes they don't. But sometimes Netflix streams just fine and sometimes it does not during company time. And you can't believe they just told you that. Anyways, so with that in mind, folks, what are we going to do here? We're going to go definitely to PC1 and PC2. And we're going to verify this so-called intermittent connectivity that they're complaining about. So again, we're just going to use ping to verify this. Oh, and I'm going to actually just ping forever in this case. We'll just let these keep running. So I'm going to start it on PC1. Let's go ahead and start it on PC number 2. All right. All right, so as you can see here, it works, it doesn't work. 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 That's what it looks like on both of them. So this is what they mean by intermittent connectivity. It's hit and miss. Sometimes it works, sometimes it doesn't. Sometimes Netflix streams okay, sometimes it doesn't. So anyways. So we have here, I've seen this scenario before. The end user is wrong. The network is fine. That's my final answer. I love it. I love it. That's awesome. Okay. What do we want to do here? Hey, we're going to check the configs on the PCs right now just to make sure they're fine. All right. IP config 10.0.10.10 slash 27 10.0.10.3. So we're good there. IP config 10.0.10.20 slash 27 10.0.10.3. I love it. We're good there as well. Run trace routes? Sure, let's try that. Let's see what happens. So I'll let that cook on PC2. Let's go over to PC1. Back to PC2 and see what's happening. Okay, 10.0.10.1. So it's going through DSW1. It's then going to 10.40.23.5, 8.8.8.8.8. Okay, that worked. Go to PC1. That worked too. So it looks to me like we are perfectly fine when it comes to actually reaching the system, but it's intermittent, right? Like, so there are times where it works just fine. There are times it doesn't work. So we can get to our default gateway. That's working fine. We've seen with the trace, we've seen with the pings, right? Somebody says it's upstream. Could be. Misconfig on DSW2. Well, we're not even using DSW2 right now because if we go over to DSW1, we'll see that DSW1 is our active forwarder. So since it's our active forwarder, traffic is always flowing like this right now. That's a good one. Jonathan says, hey, the last time there was an adjustment here was 24 minutes ago. It's not flapping. It's good. Good eye there, Jonathan. Well done. I gotta stop drinking while I'm reading chats at the same time. You guys are awesome today, by the way. Thank you so much for making this so fun. I appreciate it. Thank you. Okay. All right, so I like this. People are saying, let's just take a look at some routing now. Good job. So let's take a look at our routing table. And if we focus on our routing table here, we'll see that we know about our network 10.0.10.0 where PC1 and PC2 live. And based on this routing table, if we're trying to reach 8.8.8.8, we have to go through the default gateway. Now, let's think about DSW2 just for a second here, because is it possible that maybe traffic could be doing this, but then maybe coming back this way? And maybe DSW2 doesn't actually have a route to that network? Maybe, is that possible? Is that possible? So let's take a look at that, right? We might as well. So if I type in do show IP route, do we know about that? Well, we have 10.0.10.0 via. Well, what's going on here? Something wrong with DSW2, but that's not what the problem's supposed to be. So it's pointing. I don't have my connected route. Down. Uh-oh. I think I lost VLAN 10 here when I was doing a config, folks. Let's check if that goes up. There we go. All right, so my routing table should be fine now. So that had nothing to do with the problem. Trust me, that had nothing to do with the problem. There we go. That's what I wanted to see. So 10.0.10.0/27 is directly connected with interface VLAN 10. And if we needed to forward it, we could go that way as well. Back out, so 8.8. So it's good. It's what I want to see. It's what I wanted. Let's pretend the other thing never happened. It's like if you're in an escape room and you ask for help from the people who run the escape room because they maybe messed something up, and you're like, hey, all right, that we're good now. All right, we're all good. So let's keep moving on though, all right? Let's move on in this path because we know that from an IP addressing standpoint, we can get there half the time. Half the time. Let's go to R2 right now and see what's going on. This is following the path. We're trying to follow the path of the packets and see what's going on. So if we're going to 8.8.8.8, folks, we'll see here that if we're going to 8.8.8.8, we can go out towards the internet. And if we're trying to go to 10.0.10.27, we're going hold on a second, I'm getting a call. It's a user in the branch office. They're telling us that the whole branch network's down right now. And now I just happen to be looking at this routing table. Wait a second. Notice what it says here, 10.0.10.0/27 via 10.45.33.2. That's this way. That's that way. Traffic is going this way. So wait a second. It's telling me the network's over there. So we better go to branch and see what's going on. Well, thanks for calling. We'll look into it. All right, we're good. So let's go over to branch right now. On branch, if I type in show IP route, what is this? That's not right. Not right at all, is it? What's it supposed to be? If we look closely, another IP addressing misconfiguration in our environment. Somebody mistyped the IP address on that router interface, because how do we get these in our routing table? We get these directly connected on the routes in our routing table by having an IP address on our interface and the interface being up. Oh my goodness. Whoever configured this, not cool. Show IP interface brief. Yeah, look at that. Show interface fast Ethernet 0/0/0. Yeah, .100. Configure this 27. 10.0.10.1/27. It should be 10.0.100. Typo. So interface fast Ethernet 0/0/0.100. IP address is going to be 10.0.100.1 255.255.255.224. All right, we'll put that in there now. Now, if we type in show IP interface brief, we can now see that we're 10.0.100.1. Type in show IP route, we can now see that we have, look at that, we've learned properly 10.0.10.0/27. What else have we learned? There's our connected route. So if we go back to somebody like R2, this routing table should be different now. This routing table should be different, and we'll see that it is. So we can get to 10.0.10.0 via DSW1 and DSW2, and we can now get to 10.0.100.0 via Fast Ethernet 0.1.0. So, wow, all because we had a misconfigured IP address on another router interface, which conflicted with another subnet that we had in our environment, and it caused routing issues. So wait, we got to verify that the problem's solved. So we'll go to PC2 now. We'll ping the internet. I meant ping, not trace. Let's ping. And we have connectivity now. And is it intermittent though? Uh-oh. Let's try that. Make sure it's okay. All right, there we go. That's better. That's not intermittent anymore. Let's go to PC1. Oh, wrong one. So we keep losing the second one on both of them. But I think we're good after that. We'll do a minus T. We should be good. Okay, we're not losing any of them. So problem solved. We successfully solved our problem. Woo, I finally escaped, folks, and I get to have a weekend now, which is great. So thanks for helping me get out. Now, somebody asked, why in the world on R2 was that route being installed and the other one's not being installed? So I'm running OSPF in my entire environment, and it would have been a result of the path going this way. So I'll make this bigger for you. So the path going this way, there you go. So our path going this way to 10.0.10.0/27 had a lower cost than going this way. That's what it ended up being based on the environment. Okay. So it may not look that way from the diagram, but based on the network config and what OSPF was doing, that was the ultimate result in the end. So that's why traffic was going that way, and then in our environment. And the routing table actually would have changed a few times as well if we would have gotten into the OSPF database and looked at things. The reason why it's intermittent is because OSPF kept making adjustments on that router for whatever reason that it was doing at the time. If you want to learn more about that, you can jump into the advanced routing course. You'll learn a lot more about OSPF. But it basically boils down to that. Whoever had the better path at that moment in time was installed in the routing table because it was all OSPF routes. Yeah, bad WAN link. Bad this, bad that. Perfect. All right. So, folks, I hope you had a wonderful time with us here today in this escape room webinar. If you're wondering who we are, well, we provide training to anyone at any time they want it. We have lots and lots and lots of courses available for each and every single one of you to take advantage of. IT courses, cybersecurity courses, network, A+, Microsoft, AWS, Azure, PMP, ITIL, folks. The list goes on. And the classes that require labs to help you learn about the technologies, we can provide those to you. We got practice exam, additional study resources to help you become more knowledgeable, so that way there you can become more valuable. So we'd love to hear from you because we want to be part of your journey of becoming more knowledgeable and more valuable. We want to see you excel in your careers. We want to see you reach higher levels, and we want to be part of your journey. So don't be shy, folks. Take the time. The link is in the chat area right now, so you don't have to write this down. It's in the chat area. Just click on it right now, and it'll give you the opportunity to take advantage of an offer we have at this moment in time. But like always, there's catches, and that is the offer's only good until the end of next week. So please get in contact with us. Take advantage of this offer. And it's not just for Cisco. If you are here and you're like, hey, I like what I see, but I'd like to take a different course, I'd like to learn about something different, reach out to us. Let us know. Let us hook you up with what you need. So, folks, any other questions, comments, concerns? We strive to ensure that everyone has the opportunity to become the best that they can be. So don't be shy. Reach out to us. Let's be there for you. So any questions, comments, concerns? All right. Paul said, you already helped me pass my CCNA. That's awesome, Paul. So hopefully you're taking advantage of other things we have to offer so you can continue accelerating. Well done there. Well done, Paul. All right. Everyone else, you're welcome. You're welcome. Awesome. All right. And if you're excited about maybe having more escape rooms down the road, we can go ahead and do so. Just let us know. Don't be shy. Perfect. All right. So, folks, if you have any more questions, comments, or concerns, please feel free to chat them in. We'll be here behind the scenes for a little while longer, but I'm going to officially seal this up, shut it down. We'll get this wonderful webinar uploaded to our site so that way there you can review it again if you want to. Take care, folks. Have a wonderful rest of your day and a fantastic weekend when it arrives. and we'll see you in a future session with us here at Storman Studios. Take care, everyone. Bye for now.